Hey, AP Calculus AB peeps. All right, so here is our first set of notes, 2.1 limits graphically. So at the end of Enhanced Math 3, we did a chapter on finding limits. And you guys did phenomenal with that, especially since we were doing distance learning. Yeah, there was a little bit of some cheating, but we were able to figure that out, and the majority of you actually did not. So that was kind of refreshing. All right, so we've already learned a lot of the definition of limits. Okay, so a limit always has to do with the y value that the graph is approaching from the left and from the right. What might be a little bit new is the left-hand limit and right-hand limit, and the definitions are here, but we're going to go over that as we go through the examples. Okay, so our first example is just very basic to kind of recap how to find a limit on a graph. And so we have three graphs down there for this example, and it says the limit as x approaches 1 is 2 for all the graphs below. So as x is approaching 1, so we're approaching 1 for each of these graphs. Okay, so let's look at the first graph. As the x's are approaching 1, so on the actual picture of the graph, as we're approaching that 1 value, which looks like it's that little open circle right there, from the left and from the right, they're both meeting at the same point. So when they're both meeting at the same point, that is the limit. So the limit there is, in fact, a 2, just like it's stated up here. Okay. For the next one, it's a similar picture, except not only is there a hole, but now there's a point down there. So that point might mess you up, but it shouldn't, because it just means that though there's a hole up there, so it's not defined up there, but it is defined down here for that x value of 1. So, but that doesn't mean anything for finding the limit. I don't even need it. I just need to see what's happening on the graph as it's approaching from the left and the right, as it's approaching an x value of 1, and it's still approaching a 2. So the limit is 2. Okay. Now this one is super easy. It has no holes. It's continuous. There's no jumps, no breaks. It is just a line. And from the left and from the right, approaching an x value of 1, it is approaching a y value of 2. So the limit is 2. Okay, super easy. And that's how we were looking at graphs at the end of last semester. And yeah, okay, easy peasy lemon squeezy. All right, so here is our actual first example. The last one was just kind of going over the basics. So when we're dealing with calculus, a lot of the times the graphs are going to be really funky looking ones, and these are called piecewise because it is in pieces, like literally. It says let g be a function defined on the interval -5 to 4, excuse me. So that interval means that we're looking at only x values from the graph from -5 to 4. So only that window. So nothing outside that window pretty much exists for this purpose. And the closed brackets there, those square brackets, are closed brackets. So the x values could equal -5 and they could equal +4. Okay. So that's basically open point versus closed point. These would both be closed points there at those x values. All right, let's dive right on in. So for the first one, I have the limit as x approaches 3 of g of x. And let's see. As we're approaching an x value 3, 1, 2, 3. 3 is right there. And let us see. So there's a point above the 3, and then there's this like slanted line. The point, I can't see an approach from the left or the right because there is no approach. It's just a point. So that I don't care about. But down here, this is below the 3, and I can see that from the left and from the right, we are approaching that hole there, which is at a y value of -2. So the limit as x approaches 3 of g of x is -2. Okay. All right, next one. The limit as x approaches 0 of g of x. So 0 is right there. And so we're approaching an x value of 0, and the only part of the graph that's around the 0 is this horizontal bar right here. And so as we approach an x value of 0 from the left and from the right, we are along this horizontal line here. So we're along that y value, which is a -1. Okay. Number 3, the limit as x approaches -3 of g of x. So -3, 1, 2, 3 is over here. And I see a couple things. I see that dot, and then I see this like curvy straight line thingy over here, this little piece over here. And remember, the dot doesn't help me because I can't see the approach. So this does have an approach as we're approaching from the left and from the right. We're approaching at this value, which happens to be a +3. So the limit of x, the limit as x approaches -3 of g of x is 3. Okay. Next, the limit as x approaches 1, and then there's that little plus sign. So that means we're coming from the side of the graph, the x values that are positive. So that means we're using a right-hand limit. We're coming from the right. From the right. Okay, to +1. So +1 is right here. So from the right, so we're approaching from the right would be only at that part of the graph. And we are approaching a y value of 2. So that's the limit. All right, the limit as x approaches 1, and then there's a little minus sign. So that means that we're coming from the negative side, which is the left. So we're coming from the left to +1. So +1 is right there. So coming from the left means I'm following this bar. That's the only part of the graph that's approaching 1 from the left. And that y value is a -1. Okay. Number 6, the limit as x approaches 1. So, well, we already saw that as we're approaching 1 on the right, it's 2. And as we're approaching 1 on the left, it's -1. So if we just approach 1 from the left and the right, we're going to be at 2 different spots. One's up here and one's down here. So they don't agree. So that means that it does not exist. DNE, does not exist. The limit does not exist. Mean Girls, a movie you could watch with Lindsay Lohan, and they speak calculus. All right, number 7, the limit as x approaches -2 from the left, from the negative side, so from the left. So -2, 1, 2 is right here. Oh, can't see it, sorry. -1, -2 right here in green. And we are approaching from the left. So that means we're coming down from here, approaching from the left, and we're landing at that open point there. Well, it's on the x-axis, so that means that the y value there would be 0. Okay. Number 8. The limit as x approaches 4 of g of x. Well, 4 is right here. And we're approaching 4, and we don't have anything on the right of the graph, but that's because the graph ended at an interval of an x value of 4. So that's okay. That means we're only coming from the left just by default. And so that point where it approaches is right here to -2, -3, -4. So the limit as x approaches 4 of g of x is -4. Okay. All right, number 9, the limit as x approaches 2 of g of x. So 2 is right here. And since it doesn't have the little plus or minus, it means that we're approaching from the left and from the right. So approaching from the left and approaching from the right, we're landing at right there, a point on the x-axis, so it's 0. It's a y value of 0. All right, and number 10, the limit as x approaches -2 from the right, because we're coming from the positive side of the x's. So -2 is right there, and then coming from the right means we're going to approach this point, which is at a y value of -1. Alrighty. On to the next page. I have mine printed on the back because I like to try to save paper as much as I can. Sometimes it doesn't work that way if my pens bleed through, so I try to be strategic about that. All right, so for this next example, even in class, if we were to do this in person, we wouldn't have time to get through everything. So we're going to skip example 2, and we're going to go on to example 3, okay? Now, example 3 is important because it adds something to the graph that we probably haven't seen in a little bit, and that is these dashed lines. Do you guys remember what those are called? They're the asymptotes. Okay. So we have a horizontal asymptote here, and we have a vertical asymptote here. Okay. We dealt with asymptotes a lot last year. Okay. And so let's go ahead and answer these questions. So letter A says to find the limit as x approaches 0 from the left of g of x. So as we're approaching from 0 from the left, so approaching 0, so 0 is the origin right there. And as we're approaching 0 from the left, it just keeps going and going and going and going and going and going and going. So when it keeps going down and down and down and down and down like that, and there's an asymptote, so we know it can't cross over that boundary, it's going down to negative infinity, which means that the limit as x approaches 0 from the left of g of x is going to negative infinity. Well, in calculus, to represent it's going to infinity, we learned at the end of at the end of the school year last year, when we did the limits unit, that anytime it goes to infinity and you're finding a limit, it actually does not exist because there is no limit. It's not being limited. It is continuing on forever and ever and ever. So when you get to something like this, this is what I want done. If the limit ends up being a positive or a negative infinity, which means that the limit does not exist, I need you to give me both answers. So always give me both answers there so that I know that you know what you're doing and that you're listening. Okay. Letter B. We're finding the limit as x approaches 1 from the right, because the right side of the graph is where the positive numbers are, of g of x. So we're approaching 1. So 1's right here, and we're approaching from the right, and we're approaching a y value of negative 2. Letter C, the limit as x approaches negative infinity. So that one's a little bit different. So the x's are approaching negative infinity. So that means we're on the negative side of the graph, and it's just getting bigger, 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 bigger. So it's going towards negative infinity. So that's where it would be. So as we're going that way, basically, what's happening? Well, remember, the limit is the y value. So there's this horizontal asymptote up there, and this is approaching that horizontal asymptote, getting closer and closer and closer to it, but it's never going to touch it or cross it. So it is approaching a number, and that y value that it's approaching is a 4. All right, letter D, the limit as x approaches 4 of g of x. So 4 on the x-axis is right here. So as we're approaching 4 on the graph, from the left and from the right, we're approaching that hole right there, which is at a y value of 1. Letter E. Now this one's a little bit different. It's saying g of 4 equals. So it's asking you what the y value is at an x value of 4. So here's our x value of 4, and on the graph we have an open point. So that's undefined there, so that's not it. But right below we have a solid point. So that's where it is defined at. So when the x value is a 4 there, the y value is a negative 3. Letter F. The limit as x approaches 3 of g of x. So as we're approaching a 3 is right here. So from the left and from the right, we're approaching this point right up here. And that y value is a 2. That's example 3. Okay. Example 4 is important because we're going to go over some notation. Okay. It says, given the graph of the function g of x below, determine if the statements are true or false. For statements that are false, explain why. So since we have to do some explaining on the false part, what does that mean? Well, since we're talking about limits, if it's false, that means that the left and the right don't agree. Okay, that means when we're approaching on the graph from the left and the right, they're going to be in different spots. They're not going to meet at the same point. Okay, so that's what we're looking for. So that's what it means in words. When we write it down and we're saying our reason why it's false, if it is false, we have to show mathematically. We have to show the notation. We have to speak calculus. Okay, so that's going to be important for you guys. All right, so the first statement is the limit as x approaches 1 of g of x equals 2. Okay, so 1 is right here. And as we're approaching 1 from the left and from the right, we're approaching in two different places. So they're not in agreement. So the limit does not equal 2, because if it were only approaching from the left, then it would be 2. But approaching from the right and the left, they're in different spots. So this is a big fat false. And now we have to say why mathematically, and this is how you do it. Well, since it's different, they don't meet in the same spot from the left and from the right, we have to say the limit as x approaches 1 from the left of g of x does not equal the limit as x approaches 1 from the right of g of x. Okay? For the next one, it says the limit as x approaches c of g of x exists for every value of c on the interval -1 to +1. Okay, so on an interval from -1 to +1, that means we're looking at the x values only from -1 to +1. So that means we're not looking at anything outside that interval. So in that interval, does the limit exist for everything? So I'm just looking at this little v here, okay? And I notice there's no jumps or breaks. It's continuous. So yeah, if I were to pick any number along this interval from -1 to +1, I would find a limit. There would be a y value that it's limited at. Okay, so this is true. Okay, and the true ones we don't have to explain, so that's kind of nice. Last one. The limit as x approaches 2 of g of x does not exist. Okay, well, let's take a look. We're approaching 2. So the part of the graph above the 2 is over here. And as we're approaching from the left and the right, well, aren't we meeting at the same point there? Wouldn't it be 1? So this is not true. This is false because the limit does exist. Okay, so how do we say that? Well, it's going to be kind of like how we said it in the first one. Well, we can say the limit as x approaches 2 from the left of g of x equals the limit as x approaches 2 from the right of g of x. And that's the notation. All right. Turn the page onto the next one. This is the last page for the notes. Okay, example 5. There's 2 examples here, or 2 graphs here. We don't have time to do both, so we're gonna skip that one. But that's okay. This one's gonna have everything that you need as an example. Okay, so it says sketch a graph of a function that fits the requirements described below. So we're going to sketch a graph based on the clues that we are given, okay? So let's look at what we have. It says at the top there, it says the limit as x approaches -2 from the left of f of x equals -infinity. And it also says the limit as x approaches -2 from the right of f of x equals +infinity. Okay, so because these are equaling a -infinity and a +infinity, that tells me that the graph is undefined at this number, this x value of -2. And I also know that when it's undefined, it's either going to be a hole or an asymptote. But when I think about it, as we're approaching a -2, so they're both approaching -2. On the left, it's going down to -infinity. On the right, it's going up to -infinity. So it's never crossing over that line at -2. So that tells me that this is a vertical asymptote. When I write vertical asymptote, I put VA to abbreviate. So a vertical asymptote exists, and that's because of these bad boys right here. Okay, so let's go ahead and add those to our graph. I'm going to add a vertical asymptote at x equals -2. So through the x value -2, I'm going to draw a dashed vertical line, and that signifies that boundary that we're never ever going to cross. Okay? Along with that same clue that we were given, I'm also going to go ahead and try to draw the picture of the graph. So I know that as x is approaching -2 from the left, it's going down to -infinity. So I know that it's going to hug that wall going down. I don't know what else it's doing, so I'm just going to leave it like that for now. Okay, because remember, we're just trying to sketch a graph of the function by the clues they gave us. But if we don't know everything about this function, that doesn't mean we're going to get it exact. We just can only use the clues that we're given. All right, for the other one, it's approaching -2, but on the right, and it's going to +infinity. So +infinity is going up, because that's, remember, the limit is the y value, so it's going up +infinity. So I know it's at least doing this. Okay, for right now. We still have 2 more clues. Okay, it says f of 2 is undefined. F of 2 is undefined. So I know down here where the x value is 2, it's undefined somehow. So when it says undefined, it could be a hole or it could be another asymptote. So let's continue on and see what else it says, because that connects it with this word but. But the limit as x approaches 2 of f of x exists. So because the limit exists, that means it's not an asymptote, because if it were an asymptote, the limit wouldn't exist. But it's undefined, so that means it must be a hole, because we know with a hole, the limit can't exist. We saw examples of that on the first page. So there's a hole there somewhere at that x value of 2. So it could be at the point 2, 3. It could be at the point 2, -3. It could be at the point 2, 0. We don't know where that hole is. So because answers are going to vary with this one, because we don't know exactly where that hole is, we just know the x value is a 2, put it wherever you want. So I'm going to go ahead and put it, because if I put it up here, then I'm going to have to make my graph go up, and I don't want to do that. I want it to kind of flow, so because I want my picture to look good at least. So I'm going to put it down here. Okay. And I'm going to go ahead and connect that. And I guess I can make it go down, or I can make it go to the side. It doesn't matter, because I don't have any more clues, so I don't know what else the graph is doing. And also on the left of that asymptote, I don't know where this is going. It could be making a little parabola, or it could just keep going. So I'm just going to show that it's going to keep going here. Okay, because I don't have any more clues, so I don't know if the graph that they're talking about exactly looks this way, but these are, at least using my clues, this is what I'm getting. Okay, and if you were to do this on your own, you might have a hole at up here somewhere or way down here. It doesn't matter. It depends on how you use that clue or how it flowed with the way you started it. So answers vary on that one. Okay, and we used our clues. It's kind of nice putting a puzzle together. That's what it makes me think of. All right, example 6, our last example, and this one is the longest one here. Sorry, I needed some water, and I'm out. I reached my ice. Okay, oh, we're not looking at that. Okay, so it says graph the piecewise function given below. Now, I know that a lot of us, or a lot of you guys, really hate graphing, and believe me, when I was your age, I was in the same boat. But then in college, in those math classes, you have to graph all the time. You just kind of get over it. And once you get over it and you realize, hey, I have to do this, it makes it a little bit easier to just do it and just take it. So just have to jump that hurdle, get over it, and you'll be all right, okay? So it's a piecewise function, so it's going to go in pieces. So all of these are linear. The first one is f of x equals negative x plus 1. So if you think of mx plus b, you think of the slope and the y-intercept. So our y-intercept would be 1, and our slope would be that negative 1 in front of the x there. Okay, but this part, we're only going to graph the part of the line that appears in this interval from 0 to 1. Okay, and I have a less than or equal to next to the 0, so that means I can have an exact point at 0, but at the 1, I don't have the or equal to bar, so I can't have an exact point at 1. It has to be an open point, okay? So what kind of helps is, well, from 0 to 1, the only whole numbers I have are a 0 and a 1 that I could plug in, okay? So I'm going to plug in a 0. So negative 0, which is just 0, plus 1 is 1. So 0, 1 is the first point. When x is 0, y is 1. And it can be a solid point because I had the or equal to bar. If I plug in a 1, negative 1 plus 1 is 0. So 1, 0 would be right here, but I can't put a solid point because I didn't have the or equal to bar. So it is an open point there, and this is the piece of the line that they wanted. Okay. The next one, f of x equals 1. That's the same as saying y equals 1. So y equals a number is a horizontal line. So if it's y equals 1, that means it's this horizontal line through the 1, okay? But it's not the entire line, it's just a piece of it. And the interval that it's on is from 1 to 2. So from here to here, okay? From here to here, because it's going through y equals 1. Well, at 1, I have the or equal to bar, so I can have a solid point. At 2, I don't. So that's got to be an open point. Oh, I wanted to use a different color for that part. Let me go over it with teal. I want it to look different. Okay. All right. For the third one, it's basically f of x equals 2, so y equals 2. But then it says x equals 2. So that means it is exactly the point 2, 2. So y equals 2 at x equals 2. So the point 2, 2. Okay. When it equals, it's a solid point. The next one, now it's changing to f of x equals x minus 1 on the interval from 2 to 3. Okay. So let's plug in a 2. If I plug in a 2, 2 minus 1 is 1. But remember, there's no or equal to bar, so it is going to be an open point. So when x is 2, y is 1, it's an open point. And I already have an open point there. How about them apples? Not so bad. Okay, so I'm using that open circle that's there. And now let's plug in a 3. This time it can equal the 3, so I get to use a solid point. 3 minus 1 is 2. So that means 3, 2, I have a solid point. And remember, these are connected because they're part of the same function. Okay, because this is a line. This just means that the y-intercept was negative 1, the slope is 1, so down at negative 1, I'm going up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. All right, last one. F of x equals negative x plus 5, and it's on the interval from 3 to 4. I can't equal the 3, but I can equal the 4. So let's plug in a 3. And so -3 plus 5 is 2, so it's the 0.32, but I can't equal that, so it's an open circle. So I'm just going to put a ring around that closed point that's already there, but the closed point is overtaking it, just so we know. Okay. And then now let's plug in a 4. -4 plus 5 is 1, so 4, 1. And I can use a solid point because I have the or equal to bar, and then connect them. And there is the piecewise graph. It's really not that bad. Once you get the hang of it, and you guys will get the hang of it because you're going to have to do it a lot, just suck it up, get her done, and the more you do it, the more you practice it, the more you'll get it. But you have to try. Do or do not. There is no try. So by trying, you're doing. Okay. All right, now we're going to answer these questions. Now find the following limits. So at x equals 1, the limit as x approaches 0 from the right, that's where the positive values are, of f of x. So approaching 0 from the right, and that lands us at a 1. Okay. At x equals 1, the limit as x approaches 1 from the negative side, so from the left of f of x, so approaching 1 from the left leads us to this open point, which is at a y value of 0. So 0 is the limit. Okay. And then still at x equals 1, the limit as x approaches 1 from the right. Well, from the right, approaching 1, we land up here, and that is a y value of 1. Okay. At x equals 2 now, the limit as x approaches 2 from the left of f of x. So from the left approaching the 2, we land right here, and that is a y value of a 1. The limit as x approaches 2 from the right, so from the right of f of x approaching the same 2, I'm also a limit of 1. And then this one, I know it's cut off. It's the limit as x approaches 2 of f of x. So just approaching 2, so from the left and from the right, we're meeting at the same spot. So its limit is 1. Next one, at x equals 3, the limit as x approaches 3 from the left of f of x, so 3 from the left, and it approaches at this y value of 2. And then the limit as x approaches 3 from the right, it's also a limit of 2. The limit as x approaches 3, well, so that means from the left and from the right, meets at the same spot, so 2. And then at x equals 4, the limit as x approaches 4 from the left. So as we're approaching from the left, reaching here, and that is a 1. Alrighty. And that is everything. So your homework is attached. It is 2 worksheets on doing these types of problems. All right, so make sure you get that done. And then you have another video lesson to watch for today's lesson also. So I would stop, I would do the homework, and then when you're done with that, watch the second video, do that homework, and then boom, you're done. All right, so see you soon in my next video.